So here we have a function sine cubed of 1 minus 2x squared. I want to remind you once again, this is a single function. It is not a product. It's sine of something, the whole cubed. That's what it means. So let's rewrite it. It's f of x equals sine of the quantity 1 minus 2x squared, the whole cubed. So this is not a product. It's a single function. So if we need to find the derivative of this function, we look at the outermost function. It's something cubed. D by dx of x cubed is 3x squared. So our first step is to go 3, whatever is inside the whole squared, and what's inside is a function of x. So basically what we are doing here is we are differentiating sine of 1 minus 2x squared, the whole cubed, with respect to sine of 1 minus 2x squared. And then remember that this is a function of x, so we differentiate the inner function. We find the derivative of the inner function. That's the chain rule. Our next step, we leave this alone. Sine of 1 minus 2x squared, the whole squared, is the same as sine squared of 1 minus 2x squared times, and now we have to find the derivative of the function sine of 1 minus 2x squared. The outer function is the sine x function. So d by dx of sine of x is equal to cosine of x. But instead of x, we have 1 minus 2x squared. So we go cosine of 1 minus 2x squared. We don't touch the inner function because we are differentiating sine of 1 minus 2x squared with respect to 1 minus 2x squared. So we go times d by dx of the inner function, which is 1 minus 2x squared. So in the next step, we go 3 sine squared of 1 minus 2x squared times cosine of 1 minus 2x squared times, and now we find the derivative of 1 minus 2x squared. So I put my parentheses so I don't confuse the negative with a subtraction. Remember, it's multiplication. Minus 4x. Simplifying, I combine this term with this term and we get 4 times 3 is 12x times sine squared of 1 minus 2x squared times cosine of 1 minus 2x squared. And this completes the process of finding the derivative of the given function. And we are using the chain rule multiple times because we have a function of a function of a function. So we've used the chain rule repeatedly.